Hello everyone. The topic of my podcast presentation is DICOM, that is Digital Imaging and Communication in Medicines. Before moving on to the actual presentation, I'd like to brief you up with what exactly DICOM is. Now, we all are very well aware of the indispensable need of the technology and application of the technology in the medical field. Whenever we go on to a particular hospital or a vast medical organization, we can actually view the different complex machines and vast amount of machinery involved in any sort of test like x-ray or radiography test, where there were various medical devices present like a tomography machine, a radiography planification system, an x-ray system, etc. Now there has to be some sort of standard format so that these devices can actually communicate with each other without any complexity or without any compatibility issues. Here is where DICOM plays its part. DICOM is basically a standard for digital imaging and communication in medicine. It was developed by National Electrical Manufacturers Association in conjunction with the American College of Radiology. DICOM covers most of the formats of medicines and other image formats involved in medical data. It also provides a specification for messaging and communication between these imaging devices. Now, why was DICOM created? As I mentioned before, there are various devices, and these devices can be of belonging to different companies. So there has to be some compatibility, there has to be some mechanism so that these devices can communicate with each other without any redundancies and without any need to write the software code from one so that one machine can communicate with the other one. That is why DICOM was created. DICOM provides a large variety of features, starting from the network protocol. It provides a basis of network protocol built over the famous TCP, and allows the peers to negotiate the functionalities upon which they have to communicate with each other. It provides message encoding using 24 different data types. It also allows JPEG compression for images and other formats. It provides a vast data dictionary of approximately 4,000 different objects representing different values and tags to each of them. DICOM supports object data model. Object data model, as we've already studied here, every entity is represented in the form of a real world object. These objects can be images, reports, transfer syntaxes, etc. The operations and the services provided by DICOM are represented through the use of service classes. Now we'll deal with these service classes later. Okay, how DICOM works. The objects in the DICOM are referred to as information objects, the services in operation are referred to as service classes, and the combination of these are referred to as service object pair, SOP, which we'll be looking at. Any class or any use of a class is referred to as an instance. Okay, this is a pictorial representation. Here we can see a X-ray of the rib cage of a human being. This can be printed to and sent on to any printing device or printing media so as to take out a hard copy of it, or it can be sent or communicated to any other device like a tomography machine or a planification system where the physician can actually view it and get on to a particular diagnosis. The DICOM application domain. Now, as you see, it starts on all with the testing material. Here, as I can guess, it's an MRI machine. From this MRI machine, whatever the result is, it can be stored onto a central information management system. This information management system can be used to retrieve by query or other mechanisms, and the data retrieved from this can be sent on to any media exchange, to any other device, or to any print media for the hard copy purposes. The service object pair. As I discussed earlier, the combination of the service classes and the information objects are referred to as the SOP, or the service object pair. In DICOM, every class or everything is assessed in the form of an SOP. Just a pictorial representation of an SOP. Here it's an information object which can be taken on from the data dictionary, plus the service element, DIMSE service element, which are commonly referred to as DIMSE, gives you an SOP or a service object pair. Now, the DICOM model of a real world. As you can see, a patient enters, he visits a doctor. The doctor refers to him for some sort of an examination. This examination may lead to a result which may be in the form of a report or a therapy. The examination can further contain series which may be references from others or may be produced by some devices. They may contain an image, an annotation, a curve, graph, radiotherapy, or any other such device or object. The possibilities of a DICOM in nutshell. Now, DICOM is just not an image or a file format, it is rather a network protocol which is built over the TCP and is designed to store and transmit medical data. DICOM covers all areas of digital medicine. As I discussed earlier, it provides 4,000 different standardized keys referred to as DICOM dictionary to convey the various medical formats and the data formats. Along with this, it provides features for image acquisition, like this may be like brightness or contrast, thickness, image thickness, slice thickness, image exposure parameters, and etc. In short, DICOM allows us to capture the image and view it from different angles, different degrees, different parameters, different contrast and brightness, so as to allow the physicians and the doctors to get on the exact diagnosis. Examples: this is just a picture of an actual machine which is using this DICOM. We can see a picture which is viewed from different angles through different contrast and different parameters depending upon the need of the physician. PACS, Picture Archiving and Communication System. Now this is actually a system which uses DICOM in conformance. It allows a standard interconnectivity between the DICOM and the actual PACS system. They include archiving servers and diagnostic workstations integrated with digital image acquisition devices. It includes all the hardware and software that is needed and to run a digital medicine workflow. This is just a actual PACS system in work. You can see it's a PAC workstation which provides different sort of menus to do different things on it. Now, DICOM advantages. DICOM offers vast variety of advantages ranging from machine independence that it offers. It has very low memory requirements. It can be universally applicable. It has direct access to information. It allows compression, which is JPEG compression, and provides excellent image quality. It has certain weaknesses. Most important weakness is that it is quite complex to understand and handle directly. Again, it has to be explicitly integrated, and without integration with actual devices it is nothing. Conclusion: DICOM is the boss of digital medical applications for data and images in medical activities. DICOM has several parts which describe the procedures of digital object to analyze. It uses several formats of compression for both images and text. That would be all. Thank you.